Welcome to the ClearPath OS 2200 technical update on the GENF feature. My name is John Hendrickson. I am a principal engineer in the exec development group. A majority of the requirements for this feature were driven by a collection of client new feature suggestions. A subset of the requirements support the ongoing Unisys $8 remediation effort. The following list of requirements is addressed with this feature. Time handling in the run scheduling complex must use timestamps that are longer duration than time since midnight, not be degraded by a system reboot, continue to be based on local time, and not use $8 format timestamps. The print queues, run scheduling queues, and each run's tailsheet messages must be located within separate files. The file containing the print queues and the files containing the run scheduling queues and tailsheet messages must be capable of being separately or collectively initialized. An individual run exceeding its maximum number of staged tailsheet messages must not affect the ability of the system or other runs to operate normally, provided there is adequate mass storage available. I'd like to start with a design overview. In the past, the method of time handling in the run scheduling complex could lead to runs starting hours after their intended start time. The simplified root cause of this issue was that the run scheduling complex operated using time since midnight timestamps. For example, if a run start time was specified for a particular elapsed time from the run scheduling time, and that start time fell between a system stop and the subsequent recovery, then the run would not start until the following day at the specified time of day. This feature addresses these issues by altering the time handling in the run scheduling complex to use time since epoch timestamps with local time base. Local time base has the benefit of being able to specify a time of day start time for a run and have it start at the same local time each day, whether or not a seasonal offset is in effect. With this approach, there is limited ambiguity in determining whether the intended start time for a run has passed. The limited ambiguity exists for systems running with a non-zero seasonal offset when local time goes backwards once per year. This feature removes the run scheduling queues, run scheduling error messages, and run tailsheet messages from the GENF file. The version number in the GENF table of contents is incremented to 2. The format and handling of the remaining contents of the GENF file is unchanged. This feature introduces the new SCHQ file to contain the run scheduling queues and certain run scheduling error messages that can occur prior to the actual existence of a run. The SCHQ file has the same size, table of contents format, basic structure, and allocation method as the GENF file. The initial SCHQ file version number contained in the SCHQ table of contents matches the updated GENF file version number of 2. Two key goals of this feature were increase the number of staged tailsheet messages allowed for each run, and minimize the possibility of runs impacting each other or the system based on their volume of staged tailsheet messages. To meet these goals, this feature extends the use of run event files to all runs, whether or not the site formatted tailsheet configuration parameter is set to true. OS 2200 now allocates a temporary run event file in an exec name section for each run in the system. Each run event file can hold up to 262.143 tracks of staged information, such as tailsheet messages. With this feature, the handling of run event files is fundamentally unchanged when the site formatted tailsheet configuration parameter is set to true. When the site formatted tailsheet configuration parameter is set to false, there are important differences in the handling of run event files. In this case, OS 2200 skips creating certain run event entries unique to the site formatted tailsheet feature. In addition, at run termination time, OS 2200 prints the run staged tailsheet messages to its print file and immediately releases the run event file. If available mass storage falls below the threshold value at which an initial reserve request will cause rollout, OS 2200 will stop writing additional messages to the run event file for a run's tailsheet. In this case, all tailsheet messages continue to be logged to the system log file. When a run terminates, all tailsheet messages that were able to be written to its run event file are printed. When a system is booted with jump key 9 set, the following messages are displayed on the system console. GENF $recatalog will cause the loss of all queued print files. SCHQ $recatalog will prevent the recovery of any runs. Do you want to recatalog GENF and or SCHQ? Answer GENF, SCHQ, both, or none. Answering GENF or both to the message causes OS 2200 to catalog or recatalog the GENF file, delete all standard print files, and initialize the print queues. Answering SCHQ or both to the message causes OS 2200 to catalog or recatalog the SCHQ file, delete all copied started runstream files, and initialize the run scheduling queues. Answering SCHQ also results in exec8 being displayed by the SQ key as the run ID of all existing non-standard print files. Answering none to the message causes OS 2200 to proceed with normal GENF and SCHQ recovery. When migrating from a level without this feature to a level with this feature, the answer to the message must be both. Now let's look at some migration considerations associated with the GENF changes. When booting a level of OS 2200 with this feature for the first time, the GENF file must be recreated, the SCHQ file created, and both files initialized. The operator must initiate this process by performing a jump key 9 boot and answering both to the jump key 9 query so that OS 2200 automatically does the necessary file creation and initialization. In this case, OS 2200 also deletes any copied started runstream files and standard print files remaining from a previous boot session. When booting without jump key 9 set, OS 2200 checks for a GENF or SCHQ version mismatch. If it detects a version mismatch, OS 2200 now displays a console message informing the operator that the booting process cannot continue and that a reboot with jump key 9 set is required. A crossboot change is required. The PLE number is specified on the slide, that when cross-booting back without jump key 9 set will notify the operator that the booting process cannot continue and that a reboot with jump key 9 set is required. When cross-booting back from a level of OS 2200 with this feature to a level without this feature, the operator must perform a jump key 9 boot and answer Y to allow the GENF file to be recreated and initialized. Cross-booting back without the PLE applied and without jump key 9 being set results in the GENF table of contents version number being changed from 2 to 1 and the symbiont queues and run scheduling queues being initialized without an opportunity for the operator to intervene. Existing copied started runstream files and the SCHQ file are not deleted. This method of cross-booting back is not supported and may have unpredictable consequences going forward. Thank you, and this concludes my presentation.
Unisys offers a comprehensive set of ClearPath Forward services to enrich the value of your ClearPath Forward applications, data, and systems. Please contact your Unisys representative for more information.